Hello everyone! In this video I'm going to talk about the various aspects of security and how Azure and Azure Database for MySQL can help you when building a robust, secure and performant environment for your data-centric applications. Azure provides the most comprehensive protection for your applications and data with several security features and privacy controls built in, so that you can innovate and build your applications with confidence. Azure provides best-in-class security that ensures applications and data workloads are continually protected from bad actors and rogue programs. Azure Database for MySQL Flexible Server offers various encryption features, including encryption for data, backups, and temporary files created during query execution. Data in MySQL instances is encrypted at rest by default. Any automated backups are also encrypted to prevent potential leakage of data to unauthorized parties. This encryption is typically performed with a key that is created when the instance is deployed. In addition to this default service encryption key, administrators have the option to bring your own key. When using a customer-managed key, it is very important to understand responsibilities around key lifecycle management. Customer keys are stored in an Azure Key Vault and then accessed via policies. Azure Key Vault is a service in Azure for securely storing and accessing secrets. A secret is anything that you want to protect with tight security controls, such as API keys, passwords, certificates, or cryptographic keys. It is important to follow all recommendations for key management. The loss of the encryption key will mean that you no longer have access to the data. As a best practice, it is our recommendation to use a vault per application, per development, pre-production and production environments, and also per Azure region. This helps ensure that you do not share secrets across environments and regions. Also, you need to secure access to your key vaults by allowing only authorized applications and users. It is recommended that you create access policies for every key vault. Data can be encrypted during transit using SSL TLS protocol, and this is enabled by default. However, I want to call out one important thing. You may have to modify your application to support SSL TLS protocol, and you may also have to configure the appropriate TLS validation settings. Azure Database for MySQL Flexible Server supports encrypted connections using TLS protocol version 1.2, and all incoming connections with TLS version 1.0 and 1.1 will be denied by default. For your specific scenario, it is a good idea to read the documentation article on how to connect using TLS SSL. Once you have created the users in your MySQL databases, define the privileges in the MySQL databases schema, and configure data encryption at rest, you should pay attention to the network data flows. Azure Database for MySQL provides several mechanisms to secure the networking layers by limiting access to only authorized users, applications, and devices. When you create a new instance of Azure Database for MySQL Flexible Server, you have two ways to configure connectivity to your servers. You can use private access configuration, which means that your flexible server will be deployed into your Azure Virtual Network. Azure Virtual Networks provide private and secure network communications between the Azure resources using a private IP address. The other option is to configure connectivity with the public access configuration, which means that your flexible server is accessed through a public endpoint. In other words, the public endpoint is in the public internet address space and publicly resolvable using domain name services, or DNS. This is where firewall rules come into play. When you create a new flexible server instance with public access, you need to define allowed IP addresses, which refers to a range of IP you choose to give permission to access your server. These permissions are called firewall rules. Whichever option you choose, your users and applications will still need to authenticate to the MySQL server with valid credentials, and connection encryption is available for your network traffic. Also, remember that these options control access at the server level, not at the database or table level. You would still use roles properties in MySQL to control access to the databases, tables, and other objects. Also, remember that when a flexible server is deployed to a virtual network, you cannot move it to another virtual network or subnet. If you are hosting your application in Azure App Service, there are some security-related best practices that you need to remember. Whenever possible, use the App Service Authentication module to handle authentication and authorization instead of writing code in your application that handles that piece. Azure App Services allows you to integrate a variety of authentication capabilities into your web application or APIs without implementing them yourself. You can also use the built-in authentication to integrate with logging providers such as Azure Active Directory, Facebook, Google, and Twitter. Make sure that the web client connects to your application using HTTPS protocol. This can be achieved by redirecting all the HTTP requests to HTTPS, which provides an encrypted connection between the web clients and your application. A third very important best practice is to secure your application data, such as database credentials and API tokens, by storing and managing them in Azure Key Vault. There are many other best practices as well, and you will find a comprehensive list in Azure App Service documentation. If your application is using Azure Kubernetes Service to run containers and microservices, you want to make sure that you implement ways to manage access to its resources and services. This is important because your Kubernetes cluster developers and application owners need access to different resources in the cluster. Natively, Kubernetes lacks an identity management solution to control the resources with which users can interact. But in Azure and with Azure Active Directory integration, you can create roles that define access permissions to resources and then bind those roles to users or groups from Azure AD. This mechanism allows you to secure your AKS cluster the same way that you would secure access to your Azure subscriptions. You also want to make sure that container and container image security is a priority while you develop and run applications in the cloud. For example, you can use Microsoft Defender for containers to scan your containers for vulnerabilities. By following all the security best practices and leveraging some of the built-in security features in Azure, you will be able to build and deploy scalable, well-performing, and secure web applications that are protected against various kinds of attacks and other security vulnerabilities. I hope you enjoyed watching this video. Thank you.